Solar power is one of the clean energy sources that can help reduce greenhouse gas emissions and combat climate change. But how does solar power work when the weather is not sunny? And how did an area of high pressure over Central and Northwest Europe lead to sunny conditions and increased solar power generation? Solar power plants use different technologies to capture the sun's energy and convert it into electricity. Some of them use photovoltaic cells, which directly convert sunlight into electric current. Others use concentrating solar power, which use mirrors or lenses to focus sunlight onto a receiver that heats a fluid, which then drives a turbine or engine. The amount of solar power that can be generated depends on several factors, such as the angle and intensity of sunlight, the efficiency and design of the solar panels or mirrors, and the availability of storage or backup systems. Clouds can reduce the amount of sunlight that reaches the solar power plants, resulting in lower power output. Rain can also affect the performance of solar power plants by washing away dust or dirt that may accumulate on the panels or mirrors, reducing their efficiency. However, not all clouds are bad for solar power. Some types of clouds can actually enhance the solar radiation by scattering or reflecting it from different directions, creating a diffuse light effect. This can increase the amount of sunlight that reaches the panels or mirrors, especially if they are tilted or have a tracking system that follows the sun's movement. In May 2023, an area of high pressure dominated over much of Central and Northwest Europe, creating sunny and calm conditions across the region. High-pressure systems are associated with sinking air that prevents cloud formation and precipitation. This resulted in clear skies and high solar radiation levels, boosting the solar power generation in countries like Germany, France, Spain, Italy, and the UK. According to The Guardian, this led to a situation where renewable energy sources, such as solar and wind, produced more electricity than the demand in some parts of Europe, causing power prices to dip to negative values. This means that some electricity producers had to pay consumers to take their excess electricity off the grid, or reduce their output to avoid overloading the system. Negative power prices are not uncommon in Europe, especially when there is a mismatch between supply and demand due to weather conditions or market factors. They can also encourage consumers to shift their electricity usage to times when there is more renewable energy available, reducing their carbon footprint and saving money. Solar power is a clean and abundant energy source that can help reduce our dependence on fossil fuels and fight climate change. However, it also poses some challenges for grid management and integration, as it depends on weather conditions and varies throughout the day and year. Therefore, it is important to have a balanced mix of renewable energy sources, as well as storage and backup systems, to ensure a reliable and affordable electricity supply for everyone.